Okay, so let's finish up looking at the conversions and metric system. So we were looking at the metric system, and we said you have your base unit, and then you have a whole bunch of different prefixes from the metric system that we can use, like deca, hecto, kilo, mega, giga, tera. These are all ones if you're dealing with something bigger than the base unit, like bigger than a meter, like a kilometer or a megameter. We were just at tera when the bell rang, and tera is a capital T. And so 1 terameter would be equal to 1 times 10 to the 12th meters. You would hear of mega, giga, and tera in computers, like terabytes and terahertz are the new computers. Older ones would be giga and mega. Okay, and if you look at the sheet I gave you from the other day, you'll see more, and that's a misprint. There's no T there. You'll see more above tera, like peta and exa and zeta and iota. But in our work, we won't go that high, but I just figured there'd be some of you that would like to know it. So then you can also go down to smaller than a meter. And the first step down, smaller than a meter, is a deci. Now, the only place in physics that you'll hear deci is when we do sound. We'll talk about a decibel. A deci is a small d, so 1 decimeter would equal 1 times 10 to the negative 1 meters. Or in other words, there's 10 decimeters in a meter. Okay? Then next up is centi, which you should know well. So it's a small c, and 1 centimeter is equal to 1 times 10 to the negative 2 meters. In other words, 100 centimeters in a meter. Okay? After centi is milli. Small m. We use the capital M for mega, the big guy, small m for milli. So 1 millimeter is equal to 1 times 10 to the negative 3 meters. In other words, there's 1,000 millimeters in a meter. We don't do to the 4th, we don't do to the 5th, the negative 4 or negative 5. The next one is negative 6, and it's a micro. Okay, 1 times 10 to the negative 6 is tiny. We're on the microscopic plane here. Okay, now we can't use an m because we use the capital M for mega. We use the small m for milli. So now we go to the Greek alphabet and we use the Greek m, which is called mu. And it looks like a U with a front tail. It's called mu. So 1 micrometer is equal to 1 times 10 to the 6th meters. In other words, 1,000,000 micrometers in a meter. Okay, 10 to the, put the negative on there. 10 to the negative 7 doesn't exist, negative 8. The next one is negative 9, and it's a nano. Small n, 1 nanometer is equal to 1 times 10 to the negative 9 meters, or 1 times 10 to the positive 9 nanometers is equal to 1 meter. And then the last one that we'll have anything to do with is pico. It's a small p, and 1 picometer is equal to 1 times 10 to the negative 12 meters. In other words, 1 times 10 to the 12th picometers in a meter. Okay, and again on your sheet you'll see there's others. There's octo and zepta and 8 auto. Yeah, there's all kinds. Now in real life, which ones of these will we use in physics? Well, obviously we'll use the base unit. We'll use centi. We'll use milli, probably micro, and I think once nano. And again, once this deci, but when we get there, we'll talk about it, so don't stress. You won't see deca, you won't see hecto, but you will see milli, mega, and maybe giga. So the ones we use are the ones, with the exception of the centi, are the ones that are a factor of 3. Okay? Now, in your homework, you might use more than what I have starred, but that's okay because you have the whole chart. Okay, but when we're working in class, when we get into physics, really it'll usually be milli, centi, kilo. When we get to light, maybe some micro and nano, but not until then. Okay, now don't stress about this base unit, because it doesn't matter what the base unit is. It might be gigahertz, it might be megawatts. The unit itself, like the meter, the gram, doesn't change what the prefix is. It's the prefix that tells you how big it is. So when we get to conversions then, let's suppose we have 142 gigawatts, and I want you to convert that into something in watts. So we want to get rid of the gigawatts, which means it needs to go on the bottom, and we want to be left with the watts. So when we remember, the conversion factor has to be equal to 1, and when we put the gigawatts on the bottom, it'll cancel out, and then we'll be left with just the watts. So what we said in class was always put put 1 on the bigger number. So gigawatt is bigger, and how many watts in a gigawatt? So you go up here and you say, oh, well, there's 1 times 10 to the 9th meters in a gigameter, so there must be 1 times 10 to the 9th watts in a gigawatt. So you put 1 times 10 to the 9th here. The gigawatts cancel, multiply by 1 times 10 to the 9th, divide by 1. 142 times 10 to the 9th watts. Now, but this is not in proper scientific notation. You need to move the decimal. Remember, the decimal needs to be between 1 and 9. So it needs to go there. So your final answer will be 1.42 times 10 to the, we're moving it to the left, so it gets bigger, 10 to the 11th watts. Final answer. All right. How about if we go the opposite way? What if we had, I don't know, 63 meters, and, or maybe I'll make it 63 grams just because, and I want you to change it into micrograms. Okay? So grams need to go on the bottom, micrograms on the top. So again, the base unit doesn't matter. It's just the prefixes that we're worried about. So in a micro, we know that there's 1,000,000 micro in one base unit. Always put the 1 on the bigger guy, and that'll save you from using negative exponents. So this is 1 times 10 to the 6th micrograms in a gram. And so now when you multiply through 63 times 10 to the 6th micrograms, not in correct scientific notation again, so you need to move the decimal, and you will get 6.3 times 10 to the 7th micrograms. Okay, as your final answer. Now, just as a little side note, there is an error on one of the sheets, and I should show it to you. On this sheet that says scientific notation, when converting 4.7 nanometers to meters, that should be a positive to the 9 down here. Because, so meter is bigger, put a 1 there. How many nanometers in a meter? 1 times 10 to the positive 9. The answer's correct. I think I probably just copied it wrong. Okay? So there are some more examples here. Megas and kilo converting to grams or nanometers. Okay, so it shows you some more examples that you might want to practice before trying the conversion sheet. In the next video, I will talk for a minute about meters per second and kilometers per hour. Okay?